Howdy, Black Hat. How's it going? I hope that this show has been everything that you wanted it to be for whatever reason you're here. If you are heading out after the show, safe travels home. And if you're staying for DEF CON, stay weird. So, who am I? My name is Trisha Howard, aka Trisha Kicks Sass. That's SAAS. And I represent Akamai Security Intelligence Group. That is our hundreds of researchers across the globe that work in security research in one faction or another, from building our products and improving our products to keep our clients safer, to what threats are happening out there in the world today, and people looking for tomorrow's threats as well. And I have the coolest job, which is working with all of those and intersecting and telling all of you what they're doing. And that is exactly what I'm going to be doing today. So I want to make something extremely, extremely clear. I will probably iterate this several times throughout this. This is not my original research. I am but the messenger. I did have the joy of working with David Senecal on this piece, but it was not mine. So with that being said, let's get to the protein, shall we? When we're talking about JavaScript, a lot of the time we like to talk about the server side, but the client side is just as important to discuss. If I had to distill all of this down, it comes down to risk. When we discuss risk with security, I'm not just talking about your attackers getting access to things too. We're also talking about business risk. So JavaScript is part of your intellectual property. And last time I checked, companies don't usually love when their competitors get access to their intellectual property. So you want to be sure that you are keeping that under wraps as well. The other aspect of this is making sure that the data that you are collecting, it has integrity, because you cannot accurately discuss your risk register and profile if the data that you are collecting is not accurate. So that is what we're going to be talking about today. Last, but certainly not least, this QR code will take you directly to the piece that I am talking about today. And if you want to see more research from David Senecal, he is an expert in this topic. He is a published author on this topic. Click on his name and you will be able to read all about it. Okay, so just like anything else in security and frankly life, there is not one solution for this problem. Wouldn't that be great? We wouldn't even have to be here if there was only one solution for this. But this is a collection of things that we use here at Akamai to handle this problem, and I'm going to be talking about each one of them relatively briefly throughout here. It is recommended that you take your environment, your risk profile, your personality, I guess, into consideration and find a little mishmash wombo combo of these tactics to suit your organization. Okay, number one, code obfuscation. So this is the most common tactic for protecting JavaScript. And if I had to TLDR it, it's take something that is super easy to understand and make it not super easy to understand. This here is an example that David had worked up. It's a very simple fingerprinting script designed to get access, details from the device. It follows sound development practices. It's super clean. Even if you don't read JavaScript, you can probably kind of figure out what is going on here. And that makes it super easy to debug and maintain, which developers love, but so do threat actors. Things that can be used for good can also be used for evil. And so it is also super easy to reverse engineer. This, not so much. If you didn't read JavaScript before, you certainly don't know what's going on now, and even if you do, you probably don't still. So this is obviously the making things more difficult. Even if it's just length alone, this is clearly more difficult to understand and thus reverse engineer. One of the, in my view anyway, big battles in security is being able to exhaust your attacker and make them move on. Their time is money, just like ours. And if we can make them, if we can exhaust them or annoy them or frustrate them, hopefully they will move on to something else. These two things, these two functions here, do the same thing. The machine is going to do it the same way, but it's way harder for a to reverse engineer this than that. What's nice too, this was put together via Code Beautify. There are several of these obfuscation tools out there. In the event to make the developers happy, you can redo the code and in a next iteration of the code, you could obfuscate that as well. But sadly, there are also deobfuscation tools out there. So this is a great tactic, but not good all on its own. Data integrity checks. So these are little functions that are kind of sprinkled throughout your code to ensure that the outputs are indeed legit. So for this is another example that David had pulled together. For this very simple function, A, B, and C would all have to be numerical values. I just want to mention that, but in the real world, it doesn't have to be this way. What this does is A and B represents your two core functions, and then C is a unique seed to ensure legitimacy. This could be like a session token or whatever data that you're collecting. You can also hash the entire thing and compare the two outputs together. If your sender and receiver outputs are the same, it's fair to say that your code was not messed with and thus safe. So this could be based on whatever data you are collecting and your personal environment. VM obfuscation. Oh, I like this one. So this one is a lot more advanced, and it is advanced not only for the attacker side, but also the implementation side. So if you do go this route, I just, as a PSA, definitely check your vendor's best practices here, because not all code functions are supported. So we'll start there. What VM obfuscation does is it transforms it into bytecode, which makes it easy for a machine to understand, but not as easy for a human to understand, making it much more difficult to reverse engineer. Oh man. All right. So misleading and extra code insertion. We all know that one person, maybe few people, you might be this person, who tries to tell a story and they just have to include all these extraneous details that have nothing to do with the point of the story, kind of like I'm doing right now. And it can be a little annoying to listen to them talk sometimes, because you might get really excited about one of the extraneous details and then you forget what's going on, and on and on and on. That's exactly what this does for an attacker. One way to do this, especially when we're talking with VM obfuscation, is to take three similar functions, or sorry, the same function, but make their structures different. This will make the output encoding different, and thus much more difficult to reverse engineer. Okay, so this is my favorite one. All of the tactics we have been talking about previously are based on static code. And while all of these tactics are super helpful, static code is not impenetrable. It is, no code is impenetrable. I don't want to say that. But it certainly can be reverse engineered with the right amount of time, skill, and perseverance, which last time I checked, attackers are rather persistent in their attempts, unless we render the code useless. This is probably the most direct example of trying to exhaust and overwhelm your attacker. So imagine that you have thousands of different iterations with different integrity checks, because of course this is a building conversation, it's not an either or. And all of this is set up, thousands and thousands and thousands, many data integrity checks, and they're only useful for 10 minutes. And then you have it set up where it refreshes those every 10 minutes. Now, I know that we have a really quick turnaround time here in tech, but 10 minutes is awful fast. It would take, frankly, a wildly impressive amount of tech skill to be able to outpace that. So this is a really great way to really frustrate your attacker. What it'll do is force your attacker to execute the JavaScript in a browser and not know what it does. Especially when we're talking about from an intellectual property perspective, you really don't want them to know what it does and how it works. So make it as complex as you possibly can. Last but not least is in the same vein, dynamic field rotation. Dynamic, of course, being the key word here. We like things that move. Even if your code is difficult to understand, there are certain aspects of it that could be easier to understand, and fields are one of those if they're really descriptive. And when we're talking about also, if you look at the output, you possibly could figure out what the code is trying to do based on what it gives you back. So what dynamic field rotation doesn't only change the names of them, but it also changes where they are at in the code, which can give you different outputs, which can be more difficult to decipher. This again goes back to keeping things moving, keeping things dynamic, and exhausting, frustrating, annoying your attacker. All right. Thank you, everybody, for listening to me chat here today. Again, this was not my research. This was David Senecal's. If you have any questions, I will do my absolute best to answer them. And if not, I will get them to the guy who can answer them. But I really appreciate it. I hope you've had a wonderful show, and enjoy the rest of your day.